Geometric isomers, the EZ naming system, or, if you're American, the EZ naming system. First, a brief review of the cis-trans naming system to be able to compare with the EZ system. Here's an alkene which is fairly simply named as 3-hexene. If we switch these two groups, we have another molecule which you'll recognize as a geometric isomer and distinct from the first one because of restriction of rotation about the double bonds. This is also 3-hexene. You'll recognize these isomers as being disubstituted, and therefore the cis-trans naming system can be used. This one is cis-3-hexene because the two hydrogens are on the same side, and this one is trans-3-hexene because the hydrogens are on opposite sides. What happens if we have an alkene like this that is trisubstituted? This is easily named at first as 3-methyl-2-pentene. You also recognize that by switching these groups, for example, a geometric isomer is possible, also named 3-methyl-2-pentene. Now, of these three groups on the two double-bonded carbons, which ones do we consider as cis or trans to each other? We can't tell which groups to choose. The cis-trans system doesn't help us here. So this is why we need another system that will distinguish these geometric isomers. You already know from the title that it is called the EZ system. It works by first determining which group on each double-bonded carbon has the higher priority. Higher priority comes from having a larger atomic number. For example, we look at the atoms that are directly connected to this carbon atom. The atomic number for carbon is 6, and for hydrogen 1. That gives this methyl group higher priority over the hydrogen atom. On this carbon, the connections go to both carbon atoms. The priorities for them are the same. We must then go to the next connection. In the methyl group, carbon is connected to 3 hydrogen atoms with atomic number 1. This carbon connects to 2 hydrogen atoms, but also to another carbon. This carbon connection is what is called the first point of difference. And so this gives ethyl the higher priority over methyl. The process can now stop. The priorities remain the same in the other isomer, so methyl here has priority over hydrogen, as does ethyl over methyl. Once priorities are established, we look to see if the higher priority groups are on the same or opposite sides, as we do in cis-trans naming. But this time the letter E is used to indicate opposite sides, and Z for the same side. Now we can complete the naming by writing E here. Note that it must be a capital letter, uppercase, and in brackets. The letter is also italicized where possible. A hyphen must follow it. Similarly, on the other isomer, we put Z. Now, before I go on to a tetra-substituted example, I want to point out some history of this system. It is formally called the CIP priority rules and was established by 3 chemists, Robert Kahn, Christopher Ingold, and Vladimir Prelog. Kahn and Ingold were British chemists, and Prelog was from Bosnia-Herzegovina of Croatian descent. Prelog received a Nobel Prize for his work on the stereochemistry of organic molecules and reactions. Here's a photo showing the 3 of them in Switzerland. Kahn is on the left. You can see how CIP comes from their names, and priority is the new concept in these rules. They published their work in 1956. The origin of E is from the German word entgegen, which means opposite each other. The Z is from the German word zusammen, which means together, in this case, together on the same side. You might wonder why German was used when none of the 3 were German. Prelog was gifted in the languages, knowing Croatian, Czech, English, and German. He was working in Switzerland at this time, where German was his language. Prelog was a charismatic person and highly respected by his colleagues, so I will speculate that this is why German was used. Let's now look at a Tetris substituted example. This molecule has all 4 hydrogens replaced, and so is called tetrasubstituted. Its name at first is 2-chloro-3-methyl-2-pentene. Now, this carbon is attached to chlorine and a methyl group. Chlorine with atomic number 17 has higher priority than carbon with atomic number 6. The ethyl group has higher priority over methyl, as we saw earlier. So chlorine and ethyl are on the same side, thus making this the Z isomer. Let's look at 2 more, slightly more difficult examples. In this molecule, chlorine has the higher priority over CH3. Now for this carbon, it connects to oxygen and carbon. Oxygen has a larger atomic number of 8 compared to carbon 6. So the OH group has the higher priority, even though it's a smaller group than the methoxymethyl group. This makes it a Z molecule. The name is quite involved, so I'm showing it only briefly to emphasize that the point here is to determine priorities correctly. In this example, chlorine again has the higher priority over CH3. This carbon is connected to 2 carbons, so we consider this a tie and must consider the next connection. This carbon is connected to 2 hydrogens and 1 oxygen. This carbon is also connected to 2 hydrogens and 1 oxygen. So still a tie. We go another step to find the first point of difference. This oxygen connects to hydrogen, whereas this oxygen connects to carbon, which makes this group of higher priority. This group is on the opposite side from chlorine and is therefore an E designation. Again, I'll show the name only briefly. Finally, it should be noted that this system can also be used on di-substituted isomers. For example, here are the 2 simplest 2-butenes that are named cis and trans. The cis can be replaced by Z and trans by E. So in a case like this, and it's only for di-substituted alkenes, both names are acceptable. Here are 3 practice problems. You should pause and try them first. Here's the name for the first one. Here's the name for the second one. Are you surprised to see no E or Z? I put this one in on purpose to remind you always to check first if there is a geometric isomer. Here, since one of the double bonded carbons has 2 groups the same, there is no isomer, and so the normal naming is all that is required. And the third one is this. This ends the video on EZ naming.